Today we're going to be looking at the salt analysis for this year's exam, that's NECO, and the salts you'll be analyzing will be tag C, and it's what? Copper sulfate. I'm going to show you all the possible tests. This is not a question of prediction. I'm not trying to predict it, but all I'm telling you now is all the possible tests of this tetrasulfate copper 2 tetrasulfate 6 salts, which you are likely to see based on the requirements in the blue paper, the requirements paper. So when you look at that, you find out that most of these things you have here, all the things you have here, is the possible test that you're going to see in that exam. So I want you to pay attention and then watch, and then if you can pen down some things so that you'll be able to remember. You go through them again, or you come back and watch this video over and over again so that you'll be able to grab this thing. That's what I want to, because I know that this thing you're seeing today is exactly what you're going to see in your exam. It's not prediction. I'm not predicting anything. So I want you to pay attention as we go through with the first thing you're going to do there, because you test the solubility test of the salt. The salt I have here, I have the salt here, which is a copper sulfate. It's always blue when it contains water of crystallization. When there's no water of crystallization, it's always white. It's white without water of crystallization, but the blue with water of crystallization is what I have here. This one contains water of crystallization. So the first thing we're going to do here is to test the solubility by adding water. We'll add water to it. So by adding water to it, the question says that distill water and then stir, divide into, okay, let me see how I'm going to. You stir it and then divide into 3 portions. Let's see what you have here. Yeah, it's soluble. It's soluble in water. It's soluble in water. Let me see. See remains more. Okay, soluble. Let's say soluble. Soluble, giving us a light blue solution. Giving us a light blue solution. That is what we have in our observation. What we are going to do there, based on what we have, is that you can see that is a soluble. It's soluble in water. Soluble in water, giving us a light blue solution. So what are we going to do in the observation? It says that soluble and gives light blue solution. So what we have in our inference will be what? Soluble ions. Soluble ions or soluble salts. Let's say soluble salts. Soluble salt, and because of the color, we can also say that transition ions likely present. Soluble salts present. Soluble salt present and transition ion likely present. Now, why is this so? Because colored ions, colored compound is associated with what? Transition ions. That's why you have to indicate this here. Colored ions are associated with what? Transition ions, as transition metals. They are the ones that give you colored ions. Every other one does not. So any compound that has color must have something to do with that. Not group 1. Group 1, all group 1 has what? White, and they are all soluble. So now let's go down to the say that divide into 3 portions. Then we're going to divide into 3 portions. This is portion 1. This one is too much. the second portion, and then we have our, okay, let's use this. This is the third portion. So to the first portion, add dilute sodium hydroxide in drop and then in excess. So let me see if I can add drop of sodium hydroxide into this, and then I add drops of sodium hydroxide. Look at what we have. Pale blue gelatinous precipitate, as you can see, you can see the precipitate inside. That's what we have now. So what we're going to write, this is in drops. Let's see what we have in excess. Let's see what we have in excess. Let's reduce the volume so that we're able to be sure that we have small quantity. Our excess. Alright. Let's add in excess to see what you will get. The precipitate remains. Gelatinous precipitate still what? Insoluble in excess. You can see that it's insoluble in excess. So what are we going to do? So what we have here is that pale blue or light blue, pale blue gelatinous precipitates insoluble in excess. Insoluble in excess. So what we have here is what? Copper 2 ion likely present. So this is the ion that can likely give you this kind of thing. So now the next one we have there is aqueous ammonia. In the aqueous ammonia, so let's try what we have in aqueous ammonia. And they said that to the second portion, add aqueous ammonia in drops and then in excess. This one I have to be very careful with it. Let me use dropping pipettes. So I put in drop. You can see what we have. Pale blue gelatinous precipitate, that is what we have too. As you can see, that is the reaction with what aqueous ammonia. It gives us pale blue gelatinous precipitate, as you can see here. Then let's see what we have in excess. If we add in excess now, like I said, it's always nice to reduce the volume actually. So let's add in excess in this one, in this small quantity that we have. Okay, you see what we have now is deep blue solution. This deep blue solution is what we have. There's no precipitate anymore. So what do we have now? What are we going to say? Based on that, we have in drop we have pale blue gelatinous precipitate soluble. This time is soluble to give a deep blue solution. to give a deep blue solution. That is a deep blue solution, as you can see here. That's what we have. So we have already stated our observation. So what next? Here, what we have here is what? Copper 2 ion confirmed. Copper 2 ion what? Confirmed. That's what we have. So the next one, the last one now, because in this test we have two ions, one cation and one anion. The next one is say that to the third portion, add barium chloride solution, then hydrochloric acid. Now to the third portion, this is the third portion that I have. Let me reduce the volume. So to this third portion, which I have here with me, you say add barium chloride solution. I add barium chloride solution into it. Now you see we have a white precipitate. As you can see, we have white precipitate now inside here. So this white precipitate, then we add this white precipitate. Let's write something. White what? White precipitate. This white precipitate simply means that we are likely to have triazo sulfate 4 or tetraazo sulfate 6, or also carbon, triazo carbonate 4 ions likely present. These are the three ions that can give you this kind of thing, but then we don't know the actual one now. We don't know the real one here. So let's try what we have in the acid. When we add hydrochloric acid to it, so when we add hydrochloric acid, we'll be able to know exactly what we have there. So now with hydrochloric acid, so I should reduce this thing. Just want to reduce the volume. It seems to be much. So now with hydrochloric acid, I add to it the precipitate, white precipitate still remains with what? Hydrochloric acid. What does it indicate? What it means here is that since we can say from our observation, we can say in our observation that a precipitate insoluble, insoluble in what? HCl or dilute HCl. Dilute HCl. So this insoluble nature of it confirms the presence of what? Tetraazo sulfate 6 ion. Confirms. That is because these ions, triazo sulfate 6 ion, sulfate 4 ion, and triazo carbonate 4 ion, if they are present here, in addition of hydrochloric acid, they will dissolve. But tetraazo sulfate 6 ion does not dissolve when you add hydrochloric acid. That's what we use to eliminate this other one, to be sure that these two, they are not present. So the confirmation by adding this hydrochloric acid is telling us that what we have there is tetraazo sulfate 6 ion. So this is where we are going to be ending up our class for today, and we thank you so much for being part of it, for coming this far. And then if you have any question you want to ask, you can leave your question in the comment section. We will always attend to you. We will also encourage you to share, like, so that this algorithm will push our video more and more to more people, to other people that will also be interested in knowing this thing we have done so far. Thank you so much, and see you in our next video.